Okay, so we were able to write two equations with two unknowns. The first equation is from the first constraint on distance between centers, d plus d equals to 15. The other equation is because we want to have a certain angular velocity ratio, omega pinion over omega gear, which is inversely proportional to the ratio of diameters. Then we got two equations with two unknowns. If you solve this set of equation, you get that your desired sizes are the following. For small d, it's 15 over 3.565 inch. And for big D, it's 38.475 over 3.565 inch. Now, let us check for these diameters what will be the number of teeth and what will be the diametral pitch size. Okay, so first we know that in this problem, okay, you can set that from the formula between diametral pitch and number of teeth, that you have d equal to the number of teeth over the diametral pitch. Okay, now in the given, let us check if they gave us any index on the number of teeth or the diametral pitch. If not, we should try to do some, if you want, selections as we did before. So we consider a certain available number of teeth and we calculate the corresponding diametral pitch. Okay, so here in the given, they didn't impose anything on the number of teeth or on the diametral pitch. We should try to design a system that will give us the closest possible value of rotation to the gear equal to 720 RPM. So we should start to make iterations to trial and errors. Okay, so here again we have a certain common application. Okay, and we impose the value of big D and small d. We know that big D is equal to the number of teeth of the gear over the diametral pitch, and small d is the number of teeth of the pinion over the diametral pitch. So if I do the ratio here, I know that big D over small d, okay, is equal to, let's say, T, which is big T, which is the number of teeth of the gear over the number of teeth of the pinion. Okay, and as we said, we try to have, let's say, small sizes for my pinion. So I can start to take a certain number of teeth T for my pinion and check if what will be the number of teeth, the corresponding number of teeth for my gear. Okay, and as usual, I can check what is where I can start from the table. And I should not have interference. Here again, it's a common application. I can work with a pressure angle of 20 degrees. If you remember, we have seen that we can start with 13. We should have a value for minimum value of 13. You can try 13, 14. Now they started with 15, which is close to 13, to have a larger range of avoiding interference. When we tried this value, we got that the number of teeth for the gear is not is a decimal number, so this is not acceptable. And also we got that the diametral pitch is not also an integer, so which is not possible. This is why we can say that such a solution is not practical. We should not have fractions of teeth on a gear, because it's impossible, and the number of teeth should be an integer. Okay, and also we should have a an integer diametral pitch. So we can say that the closest value of integer for a diametral pitch compared to 3.565 is a value of 4. Okay, so we can set the value of PD equal to 4, and then say for this value, okay, let me try to find what should be in this case the number of T's for the gear and the number of T's for the pinion, using the formula that the number of T's is the diametral pitch times the diameter. I already calculated the diameter of my pinion and of my gear, so I can and if I impose a certain value for PD, I can calculate the number of T's. And as you can see, again, I obtained here non-decimal values. So I will say what I will do then, I will take the closest value as integers. And of course, I will not be able to reach 100% 720 RPM, but I'll be very close. So we can say that a good combination will be to take a diametral pitch of 4, a number of T's of 43 for the gear, a number of T's of 17 for the pinion, and of course, before doing this, I should check that these sizes are available. So I should go to my table of commercial sizes, go to the column of diametral pitch equal 4, and check if these sizes are available or not. If not, I can select sizes that are very close to these ones. Okay, and once all my numbers are integers, now I can find for these combinations what will be, if you want, the number of the value of omega for my gear. And I expect that this value will not be equal to 720, but will be close. Okay, so now after selecting this, I should verify I should check my equations. I have two constraints. So the first one is that I should have the distance between my centers equal to 7.5 inch. So now when I imposed the diametral pitch equal 4 and the number of T's, I can check now for my diameter for if you want the gear and for the pinion. So this set, okay, this set will satisfy the first condition, that the summation of radius is equal to 7.5 inch. So here, if you do summation of these two diameters, you will get 15, which is satisfying the first condition. Now for the second condition, I should be as close as possible to 720. Let me check with this combination. Okay, I can calculate the ratio of the number of T's. So I have 14 and 17. If I do the ratio, I have 17 over 43, and this will allow me to calculate. I know that the number of T's of pinion over the number of T's of gear is equal to the angular velocity of the gear over the angular velocity of the pinion. The angular velocity of the pinion is imposed on me. It should be equal to 1850 RPM. So now, by imposing this ratio, I can calculate what is the corresponding gear angular velocity, and you can say that I got a result that is very close to 720. Okay. Is it clear?
Yes, doctor.
Okay. So these are some design problems. We have a variety of possibilities. I will do for the other section other problems, so you can benefit from extra practice on gears. Okay, and then hopefully next week we can continue new chapters on gears. Any question before we stop?
You're gonna upload the videos, doctor, of this session and the next one, right?
Yeah, of course.
Okay.
Okay, yeah, let's see you next time. Bye. Sherbil, can you repeat your question? أي part exactly? Sherbil, are you still with us? طيب, okay. Yeah, let's see you next time. Bye.
ايه دكتور بعدني معك
ايه
قبل اخر
شربت؟
سطر E equal T over
Okay.
big T.
Just repeat for me. هون يعني ال check part, this one. Let me erase. Okay. لحديت وين بدك اشرح؟ هون؟
اوكي نحن حطينا سي هيدي تقول ايه مزبوط تو تشيك حطينا سي ايكوال يعني هيدي السنترال مزبوط. اوكي تي بلس
انت طلعت solution صح؟ قلت بدي اخذ integer numbers للdiametral pitch وبدي اخذ للتيس اقرب integer يلي هون جربت 43 للجير و17 للبنيون. اوكي؟ هلا تتاكد انه هالcombination is satisfying your constraints. انت شو كان عندك constraints؟ في وحده exact وفي وحده approximate. اول constraint انه the distance between centers لازم تكون على قد 7.5 inch. اوكي؟ يعني you should have the diameter of the gear plus the diameter of the pinion over 2 equal to 7.5. انت عملت solution بقى حطيت البي دي وحددت النمبر اوف تيز، ساعتها صار فيك تعمل calculation لبيج دي وسمول دي. and you can verify انه if you add them بيطلع لك على قد 15. يعني هيدي الcombination اللي انت نقيتها with integers numbers is satisfying your first constraint. هلا تاني constraint فيها flexibility اكثر لانه قالوا لك you should be as much close as possible to 720. يعني ما انهم جابرينك برقم بس بدك تكون close. فانت من بعد ما نقيت هالconfiguration which satisfies the first constraint حتتاكد انه انت قريب من 720. so you can calculate your omega لانه من بعد ما انت عملت calculation لل D of gear and pinion you can calculate the ratio of diameters and say that it's inversely proportional to the ratio of angular velocities. معك انه البنيون مجبور يكون الانجلر velocity تبعه 1850 وانت قررت على number of t's وعلى diameters يعني صار معك الراتيو of diameters. so the only unknown will be omega of your gear and you can check انه the value you obtain is close to 720. اوكي؟ طلع لك 731 RPM. اوكي؟ Any other question? Okay, thank you. يلا باي باي.